How to solve one-step equations using addition and subtraction. First, understand that when we say to solve an equation, we're asking you to get the variable by itself. In this case, we're dealing with x. In many cases, we will be. But our main goal here is to get the equation so that it says x equals something. And x is all by itself with a number that it is equal to. The second thing that your focus should be on here is the actual equal sign. The equal sign is what divides your equation into two sides. If we look at example 1, it says that x minus 4 equals 9. We're currently subtracting 4 from x. In order to keep an equation balanced, in order to solve an equation, we have to keep in mind that there are two sides to it, and that equal sign is what is dividing it into two sides. Anything I do to the left side, I must also do to the right side. And then vice versa. Anything I do to the right side, I must also do to the left. That's going to keep things in balance. So if I subtract on the left, I have to subtract the same amount on the right. If I add on the left, I have to add the same amount on the right. Now, with all of that in mind, how we get that x by itself, or the variable by itself, is all about inverse operations, or opposite operations. Currently, in example 1, we are subtracting 4 from x. The inverse, or opposite, of subtraction is addition. So in order to get rid of the subtraction of 4, I must add 4. This way, if I add x minus 4 plus 4, the minus 4 plus 4 gives me 0. I get x plus 0. I don't really need the plus 0, so I don't have to actually write that. I can just write that as x. But my equation isn't balanced anymore, because right now I've added 4 to the left side of the equal sign. In order to balance that out, I'm going to have to add 4 to the right side. Now, 9 plus 4 is 13. I get the final answer of x equals 13. I'm going to box that in. I'm going to highlight that. You should box it in or circle it. And that's our final answer. If we want to, and we should, oftentimes check if that is correct. To do that, I'm going to take my answer, x equals 13, and substitute back into x. If I substitute 13 for x and I subtract 4 from it, I'm going to get an answer of 9, so I'm happy. That's correct. X equals 13 in this equation. Example 2, I'm going to do slightly differently as far as I'm not going to show as much of my work, or I'm not going to show all of the highlighting, but the process is exactly the same. I have an equation because I have an equal sign. I'm going to draw this to separate my two sides of my equation. On the left side, I have x plus 12. On the right side, I have 9. I don't want x plus 12, I want just x. To get rid of plus 12, I do the opposite of adding, and that is to subtract 12. But again, if I'm going to subtract 12 on the left side, I'm going to also subtract 12 on the right side. My equation is still balanced. I don't need to write the x plus 0 line. I could go straight from here and recognize that plus 12 minus 12 is 0. That leaves me with just x. My equal sign should never move. It should always go straight down this vertical line. I can say that x equals 9 minus 12. 9 minus 12, and don't be afraid to use your calculator if you get stuck on any addition or subtraction. That's why you're allowed to use it. 9 minus 12 is negative 3. I circle or box that in. Double check to make sure we got the answer correct. If I put negative 3 in for x and add 12 to that, negative 3 plus 12 is positive 9. Again, I'm happy. Examples 3 and 4. These two problems are similar, but the major difference is I don't have my x listed first. This can be tricky, but you just have to make sure you focus on one additional thing. First step, equal sign with my dashed line or my dotted line to separate my two sides of the equation. Second step, we see addition and we automatically think, okay, if I'm going to solve, I have to do the opposite, that's subtraction. But where you have to be especially careful is, I don't care about the sign that's right in front of my x, in this case the positive sign, the plus sign. I care about the sign in front of the number I'm moving. This happens to be a positive because there was no sign there, a positive 7. That does indicate that I will subtract 7 from both sides because I need a positive 7 and a negative 7 if I'm moving it. Positive 7, negative 7 will cancel, get me 0. X equals 3 minus 7. 3 minus 7 is negative 4. I'm done. I circle it or I box it in. I can feel free to check my work. 7 plus negative 4. I put that in my calculator. I get positive 3. That means I was correct. Here's the difference. Example 4, again, I have my equal sign. It's dividing it into two sides. But this time, I see this positive, and I say, oh, it's negative 2 plus x. I should subtract. However, if I subtracted my negative 2, I'm not, or if I subtract a negative 2, I'll be fine. But if I subtract 2, I'm not, because I wouldn't have positive negative. I'm focused on all of this. If I want to move a negative 2 to the other side, I need a positive 2. That will cancel my 2's. I would need the same exact positive 2 on the right-hand side. A negative 2 plus 2 is 0. That term goes away. X is the only thing left on the left. Drop my equal sign down. Negative 6 plus 2 is negative 4. Circle or box that in. Check my work. I have a negative 2 plus a negative 4. That does give me a negative 6. I'm happy I am correct.